We're going to start today, Kevin folks, we're going to start today our discussion of mixtures. I believe that when we started out this section, that it's titled Phases and Mixtures. Well, up to this point, we've been discussing phases. Now we're going to go into some parts of mixtures. So, let's talk about some types of mixtures. Some types of mixtures. The first type of a mixture we're going to talk about is heterogeneous mixture. Now, can you remember all the way back to when you had biology prefixes and suffixes? I would imagine that you did prefixes and suffix quizzes when you took biology. I know if you had me, you did. Okay. What is hetero? Can anybody remember? Different. Okay. Hetero was different. And what was what is that? The antonym? All right. Homo. So we're going to talk about a homogeneous mixture too. But heterogeneous mixture is a mixture that is different. It is not uniform. Okay? What does uniform mean? The same. Okay? The same. If you've got a uniform for school, your school makes you wear a uniform, they're the same, aren't they? Okay? If your team has a uniform, it's the same. Well, a heterogeneous mixture is a mixture that is not uniform. Look at those M&Ms. Okay. Is that uniform or not? Definitely not uniform. How would I get that to be uniform? Take out all the colors and just have one color, right? Sure. Is this uniform? Is that uniform? You think? You're guessing? Let me ask you this. Is this spot right here the same as this spot right here? Is it uniform? No, it is not uniform. Folks, have you ever been to some place like Sherman-Williams and got paint? Okay? They've got this big machine that you can go in and you can take this color and you say, I want this color. They put a white paint onto the machine, type in that number for it, and the machine squirts a bunch of different colors into that white paint. And it'll look something like that. Just got a bunch of colors in there. Then they'll put it onto a different machine, okay? And that different machine will shake that whole paint can and just mix it up for like 3, 4, 5, I don't know, 10 minutes. And it mixes it up. And when they take the top back off of it, guess what? That color that you handed them is right there in that paint. So when they squirted it in, it was not uniform. The paint was all different areas. But when that machine stirred it up and then they opened it up, you got one color and it's ready to go on your wall. Pretty neat how they do that. I would say they probably do that at Walmart too, but I don't know. Do they have a shaking machine? Do they mix their own paint though? That's what I'll ask. I got a couple kids in my class. One works at Walmart and one works at Menards in my AP bio class. I'll ask them if they make their own paint or not. Maybe they'll know. Now here's the flip side, the homogeneous mixture. So we haven't even talked about this yet, but what do you think this definition is going to be? A mixture that is uniform, okay? A uniform mixture. So if I have a uniform mixture, there it is. I poured my little packet in, I added my water, I agitated it. What's that mean? Agitate it. Stirred it, mixed it up, okay? And my final product is my glass of Kool-Aid. Now let me ask you this. Is that first drink I take right there gonna be same as the last drink I take? Remember, I told you that this is uniform. Is that first drink gonna be the same as the last drink? It should be. Okay, it should be. But I'm sure you've all had that Kool-Aid that you made where you might have added so much sugar that there's sugar sitting at the bottom of it. Okay? I always used to do it with Nestle Quick. When I'd make chocolate milk, I'd put so much scoops of Nestle Quick in there that down at the bottom was a layer of Nestle Quick where it was not uniform. Okay? There's simply, and we'll talk about solubilities, simply I put so much of it in there that no more of it will dissolve. Okay? We used to, when I coached football, we used to see it all the time because the trainers would add too many packets of Gatorade to our big cooler. Then when you would get to the bottom of it, it was a really, really syrupy mixture, and it wasn't even like a liquid. What is a solution? A solution, by definition, is a homogeneous mixture of two or more substances in a single phase. Remember, what's a phase? Yeah, give me an example of a phase. Gas, a liquid, a solid. Two or more substances in a single phase. We deal with mixtures all the time. We deal with solutions all the time. But by definition, a solution is a homogeneous mixture. So that means that it is uniform. Now, what are the parts of a solution? Remember, as I go back, I said two or more substances. Okay? Two or more substances. So we at least got to have two parts of a solution. What are they? One is a solute. Right there. The substance that is dissolved in a solution. The second part is a solvent. A solvent, which is the dissolving medium in a solution. Now I like to use, as an example of this, something that I have almost daily. Okay? Right here, my coffee. Now, anybody that has a knowledge of coffee, okay, how is it made? What do you do to make coffee? You what? You have coffee grounds that you put in a filter, and then you run water through those grounds, right? And then the filter filters the grounds out. So what goes down into your coffee pot is water with what? With the part of the coffee grounds dissolved in it, right? So what is the substance being dissolved? The coffee grounds. So which one of those two is the coffee grounds? The solute or the solute is the coffee grounds. What is the solvent? Water. You know what? Just a little, asterisk here. The universal solvent. That's what they call water. The universal solvent, because so many things dissolve in water. So we have the water being the solute. Check. We have the water being the solvent, the coffee grounds being the solute. Now I said two or more things. Okay? I like to put a little pink packet into my coffee. If I've got a big cup like this, I put 2 pink packets in that. What is that? Solute, solvent. Solute. So in that case, in my coffee right here, I have 2 solutes, coffee grounds, the pink packet, and I have a solvent. Could I put something else in there? A lot of people put cream, right? Okay? A lot of people put cream. Every once in a while, if I go to Shell, I'll put that little vanilla, French vanilla stuff in here, just to give it a little added twist. Okay? So I could have any different number of solutes, but I only have one solvent. The substance that's doing the dissolving. Now, you might say, okay, wait a second here. Okay, it says we were talking about states. Could I have a gas dissolved in a gas? What do you think? Remington says if it has the same temperature. Right, this is probably not something that you would normally think of. This is not something that you would normally think of. But let's do it like this, people. Let's think of it like this. What is the air we're breathing right now, right? Right. We've got a bunch of different gases mixed together, don't we? What is the majority of our gas? Nitrogen, right? 78% nitrogen. What's next? Oxygen with about 21%. So 78 and 21 to me is about 99. Okay? 99. So, in that case, our solvent would be the nitrogen, because it's the most abundant. Our solute would be oxygen, and we can have other minute gases that make up that other 1%. But yeah, we could have. Okay, we could have. And we'll talk about some of those later. Okay. Here we got some talk. Well, how about now is later? A gas dissolved in a gas. And I'm going to give you some examples of these things. A gas dissolved in a gas, here we go. We're talking about our air. You cannot read this probably in the back, Sean, but it says 78% nitrogen, 20.94% oxygen. Here's argon of 0.93, carbon dioxide 0.035. Okay? So that is gas dissolved in a gas. So we have carbon dioxide, argon, oxygen, all dissolved in that nitrogen. That's the air we breathe in. Okay? So those components there make up about 99.99% of our air. How about a gas dissolved in a liquid? Anybody think of anything? Huh? There is oxygen and water. Back on our fish tank back there. Our fish tank, we're bubbling in. What are we bubbling in? Oxygen, because if I wouldn't bubble in that oxygen, what's going to happen to my guppies? They're not going to die. They'll suffocate. Well, they're not going to live. They'll suffocate. There will not be enough oxygen for their gills. You want to know another one? Your pop is carbonated, right? You know, a little carbon dioxide in there. Carbonated beverage is a gas dissolved in a liquid. What happens right when you twist the top? Yeah, you get the hiss because you're releasing gases. How about a liquid dissolved in a gas? It's getting a little bit tougher, right? A liquid dissolved in a gas. Yeah, have you ever heard of humidity? Okay. How about that? What is that? Fog, right? Fog. Well, what actually is fog? A thick cloud of tiny water droplets suspended in the atmosphere at or near the Earth's surface. And that tiny little cloud of water droplets is affecting our visibility. How about a liquid dissolved in a liquid? That's a bit easier, right? Didn't I just say creamer in my coffee? That would be an example. Here's another one. I put the drop of food coloring into the water. Once it spreads out to a homogeneous solution, I have a liquid dissolved in a liquid. How about a liquid dissolved in a solid? A liquid dissolved in a solid. Fillings for your teeth. Okay, fillings for your teeth. At one time, way back when, okay, and this is going off of memory, I believe that they used mercury for fillings. Okay, way back when. But if you look at the fillings here, okay, they have a liquid that is dissolved in a solid. Eventually, that hardens up to form the fillings of your teeth. Now, this is old school fillings. Look at these fillings now. Can't even tell, can you? Okay. Advances. The advances in dentistry from these kind of silvery looking. I mean, I would have to say, if just on a personal opinion, that probably looks a lot better than that. Just saying. Okay? Not that you even notice it. I could have fillings in my mouth and nobody'd ever know, right? Okay, once again here, mercury and silver. Used to be what? The fillings were made of. How about a solid dissolved in a liquid? Coffee grounds, right? Hey, there we go. There we go. A little coffee. How about a solid dissolved in a solid? A solid dissolved in a solid. What'd you say? Did you say gold? Right here. Here's our gold jewelry. Okay? 24 karat gold. You've heard of it. You've heard of it. It is the most expensive. All right? If you buy 24 karat gold, you're buying the most expensive gold. It's almost 99.99% gold. But what's the disadvantage of that? It's really, really soft. Okay? It's really, really soft. If you'd have a gold ring, okay? If you'd have gold rings, you might see them bending. Okay? Especially if you did a lot of this. Okay? If you did a lot of that over the years, you could see those bending. So why do they put these other impurities in this? To make it more durable. Okay? Make it more durable. I have a necklace. I have a little packer. What do you call those things? Medallion? Are they medallions? Whatever, you know what I'm talking about. I got 14 karat gold, which is about 58.3%. Okay? 18 karat gold I've heard of, 10 karat gold. But obviously, which is going to be the cheapest to buy? 10 karat gold. Now I'm going to show you another one here. If you look at this, okay, here is different combinations. Have you heard of white gold? Have you heard of white gold? Down here, if you look, okay, white gold. Here's the different colors that you can get based on the different amounts of things, okay? So, you know, up here, you get this yellow gold, okay? A pale greenish yellow, a red copper, okay? So right here, the way I'm using and reading this, okay, is if I'm getting a red gold, you know, it's going to be somewhere around 20% gold and about 80% copper. So they can change the different coloring of the jewelry with what they're adding to it. Suspensions. Suspensions. No, not when you get kicked out of school. We're not talking about those suspensions. We're not talking about when you lose your driver's license. Okay? We're not talking those suspensions. We're talking about particles. The particles in a solvent that are so large they settle out of the mixture unless they are stirred. This is what we call a suspension. Particles in a solvent that are so large that they settle out of the mixture. If you look right here, here is a liquid, and at the bottom of the test tube, we have this solid that is settled down to the bottom. We labeled that a precipitate. Have we dealt with precipitates in here? Yes. When you did your double replacement reactions and you mixed the two liquids together and you got a color change, remember doing that? That color change was a precipitate that was settling out. So that would be one of these suspensions. A colloid. A colloid is a particle that has an intermediate size between those in solutions and those in suspensions. So in a solution, the substance is dissolved uniformly into the liquid. In a suspension, the particles are so big that they settle out down to the bottom if they're unagitated. Well, a colloid is somewhere in the middle. They don't settle out to the bottom, but yet they're not dissolved into the liquid. In this case, we're talking about liquids. Okay. So if you look, this is what we call the Tyndall effect. And we're not going to have time today, but if you remind me tomorrow, I will show you the Tyndall effect. I've got a little demo to do. But this is the Tyndall effect. And what it is, it tells you whether you have a colloid or not. All right? Look at these two. I have this light, right? And I'm shining that light. Okay? See how you cannot see anything here, but when you get over here, you can see the light? Can you see that? Okay. This right here is a solution. You cannot see the light. Right here, this is a colloid because that light is being scattered by the particles that are floating in there. Okay? Now, my demo I'll show you tomorrow is better than this because you can see it way easier. Okay? You can see it way easier than what we can see right here. So my demo tomorrow I'll show you will be a little bit better. Okay? So this one's a solution. This one's a colloid. And like I just told you, the Tyndall effect. Okay? That's the Tyndall effect. All right, we'll save electrolytes for tomorrow. Okay? Didn't get quite as far as I wanted to, but that's not a big deal. Here.